Let's learn a new division rule for exponents. This one's called power of a quotient, and this is when you take a quotient and you raise it to a power. So the example we have here is pretty complex. Let's see if we can start with a slightly easier one just to sort of work out how this rule works. And if you remember the power of a product, this is exactly the same, which is if you have something inside parentheses like this that's raised to a power, what this means is that you take the thing in parentheses and multiply it by itself that many times. So c squared over 2 to the third power means c squared over 2 times c squared over 2 times c squared over 2. And the product of powers rule tells us that the top is going to be c to the sixth. We add the exponents. 2 plus 2 plus 2 is 6. And on the bottom, 2 times 2 times 2 is 8. So this is c to the sixth over 8. This is exactly the same as the product or power of a product rule, which is that we do c squared cubed over 2 cubed, and then we follow our product rules, which says multiply the exponents. 2 times 3 is 6, and then 2 to the third power is 8. The quotient rule is identical. So when we have this more complex quotient, it's only more complex because there's more stuff, but the math is identical. We're going to take each thing in this quotient and we're just going to raise it to the third power. I'm actually going to do the denominator first just because there's only one thing in the denominator. It's going to be 5 to the third power. The top is going to be 4 to the third power. Then I'm going to have c cubed to the third power. And then we'll have d squared to the third power. And then we use our power of a product rule, which says you just multiply the exponents. 4 to the third power is just a number, it's 64. C cubed cubed is found by multiplying those exponents together. So it's 3 times 3, which is 9. So c to the ninth power. And then we do the same thing with our exponents on d. D squared cubed, 2 times 3 is 6. So this is d to the sixth power. And then on the bottom, 5 to the third power is 125. And will 64 over 125 reduce? I don't think it will. I don't think 64 over 125 reduce. Maybe it does. Anyway, it doesn't matter. If 64 over 125 will reduce, we should reduce it, but I don't think it'll reduce. I think that's our final answer. Let's try one more. If it will reduce, whatever you do, do not tell me. Please don't tell me if I made a mistake. Let me live the rest of my life believing that I've done this perfectly. Whatever you do, don't point out my mistake. So this one's, again, it's bigger. It's not harder, just more to it. So just like at the last one, each thing inside the parentheses is going to get the third power. So in the numerator, we have 3 to the third power. The denominator will be m cubed to the third power. And then we've got n squared to the third power. Then down here we've got 4 to the third power. We have p to the fifth to the third power. And then finally we have q to the third power, and I don't need to put q in parentheses because q doesn't have an exponent. So just q to the third power. And then we just go ahead and multiply all these things out. 3 to the third power is 27. M to the third, 3 times 3 is 9. So this is m to the ninth power. And then 2 times 3 is 6. So this is going to be n to the sixth power. And then on the bottom, 4 to the third power, we did in the previous problem, that's 64. And then p to the 5 times 3 is 15, so p to the 15th. And then just q to the third power. And will 27/64 reduce? I don't think so. I don't think 24. I don't think 27/64 will reduce. So that's our final answer as well. So this is extremely similar to the power of a product rule, which is everything inside the parentheses gets that exponent, and then you just simplify as much as you possibly can. And that's really all there is to the power of a quotient rule.